अभी तो उस पे है, स्लाइड शो मोड पे।
ठीक है।
Okay, so today we will be discussing ANOVA and repeated measure ANOVA. Okay. So why it is named as ANOVA? ANOVA is short form of analysis of variance. तो ये AN जो है वो एनालिसिस से लिया गया है, O ऑफ से लिया गया है, और VA वेरिएंस से लिया गया है. सो शॉर्ट फॉर्म में इट हैज बीन मेड एज ANOVA, एनालिसिस ऑफ वेरिएंस. When T test is not capable to test the equality of more than two means, then the role of this ANOVA comes into the picture, and we test the null hypothesis that of the equality of several means. What analysis of variance, say one way touch? Let us discuss what is one way, two way, and more than that way. What we do in analysis of variance, why it is named ANOVA? While we are testing the equality of several means, but it is named as ANOVA. चेक कर रहे हैं बहुत सारे मीन्स की इक्वलिटी, लेकिन नाम रखा गया है एनालिसिस ऑफ वेरिएंस, क्योंकि हम क्या करते हैं, इक्वलिटी ऑफ मीन्स को चेक करते हैं थ्रू एनालाइजिंग द वेरिएंस. दैट इज व्हाई इट इज नोन एज ANOVA, analysis of variance. Let me put with an example. See what ANOVA does. The total variation of the data is first partitioned into the two factors, basically two
सर
sources.
वॉल्यूम नहीं आ रहा, आपका आवाज नहीं आ रही.
आवाज तो आनी चाहिए. किसी और
आवाज ठीक है।
सर आ रही है सर, आवाज क्लियर है.
आ रही है सर.
तो
इट्स
ठीक है।
ऑडिबल सर.
मैम, ये आपके साथ प्रॉब्लम होगी हमको लग रहा है. एक बार चेक करिए जरा. तो क्या कहते हैं, आपका सिग्नल तो नहीं वीक है? अभी भी वो ऐसा ही है?
कैन कैरी ऑन सर, उनका सर इशू.
ओके. अगर सिग्नल प्रॉब्लम है तो फिर थोड़ा बियर करिए, क्योंकि हम लोग उसमें कुछ कर ही नहीं सकते. So what we do in analysis of variance, first we partition the total variation in two basically sources of variations, or we can say the two, say, major factors. One is known as assignable cause of variation, and another one is known as random cause of variation. Now, what are the assignable cause of variation and what are the random cause of variation? Random cause of variations are not in human hands. Sometimes we call them that natural cause of variation as well. It is God's will. But assignable cause of variations क्या हैं, जो which are in human hand, in human control. We can eliminate them, we can identify them, we can eliminate them. But we have no control over random causes of variation or natural causes of variation. Let me put the examples. The assignable cause of variation, example for the assignable cause of variation is, say, faulty material, negligence of operator, machine का कोई पुर्जा घिस जाए, suppose die is not of order, तो क्या होगा, जो प्रोडक्ट होगा वो बायस टाइप में निकलेगा. And what are the causes of random variation or natural variation? Say all natural disasters comes into category of that. Earthquake, flood, drought, lightning, storm, एकदम से बिजली चली जाए, sudden cut of light. So these are the examples of रैंडम काज ऑफ वेरिएशन उस पर कोई कंट्रोल नहीं हमारा। अब वन वे क्लासिफिकेशन, जो वन वे एनोवा है, इसको एक और एग्जांपल से रखते हैं तो आपको ज्यादा क्लियर समझ में आएगा। अगर किसी को हिंदी में दिक्कत हो तो आई एम कंफर्टेबल विद इंग्लिश एज वेल, लेकिन अगर नहीं दिक्कत है तो ऐसे ही कर सकते हैं।
Make it in English.
Okay, so let me put this one with an example that suppose we are admitting the PG students in our university, and so the students from various colleges and from the same colleges have appeared into the entrance test, and then they have got the marks. So the variation in the marks may be identified in two ways. One, variation among the students of the same college, and the variation among the students are between the colleges. Students among the colleges. So here we have identified two sources of variation, and one is assignable cause of variation and another one is random cause of variation. You just tell me which one is random cause of variation and which one is assignable cause of variation. One is variation in marks will be among the students among different colleges and among the same college. So which one will be considered as the assignable cause of variation? Let me just tell me.
सर हेलो
हाँ बताइए।
सर which cause is better
Which
cause is better into these
मैम
two causes?
बेटर की बात ही नहीं कर रहे हैं, दो अलग अलग हैं। वी आर नॉट कंपेयरिंग द टू।
Means you usage in different particular in different areas.
See, if we know that we cannot do anything with a particular part, then first we identify that and we do nothing with that. So we identify the natural cause of variation and we eliminate from the data, or separate it from the data, not eliminate, we partition it, and we only work on the assignable causes of variation. So in this example, just tell me which one is assignable cause of variation and which source is random cause of variation.
The
Sir, may I?
students who are applying from the same university are assignable maybe, and who are like from different university are random.
Anyone else?
I can try, sir.
Yeah,
So,
try.
different colleges, different teaching patterns. Probably that can be assignable because that is modifiable. The pattern of teaching is modifiable, but within the same college, it could be a natural or a random.
Yeah, you are absolutely correct. Because there may be differences in situations. They may differ, they may have some different type of faculties, different type of facilities, like that. But in the same college, even if you will replace any faculty, even if you will be taught by the father of statistics, say RF sir, then you will get different marks. So within the college is random and between the colleges is assignable. Now, once you have partitioned the variation in different parts, basically in two parts, one assignable cause of variation, another random cause of variation. Now put random cause of variation aside. Now work on the assignable cause of variation. Now if there is only one source of variation of the assignable cause, then it is known as one way. If there are two sources of variation of the assignable cause of variation, then it is known as two-way and so on. In this example, there is only one variation assignable, that is difference in marks among the colleges. Now we come to the say example of the field, then variation in the yield of a crop depends on the type of seed and type of manure you are using. So here there are two sources of variation of the causes, that assignable causes of variation. So this will be a case of two-way ANOVA. So here we first partition, that is why if you are asked what is ANOVA, then ANOVA is a method of partitioning the total variation in different source of variation, assigning random cause of variation and that is assignable cause of variation. And if assignable cause of variation is having 1, 2, 3 and so on sources, then that way ANOVA will be that under consideration. So here it is one-way ANOVA. So here only between subject, this one is the cause of assignable cause of variation. So it is considered as the one-way ANOVA. It tests the equality of several means. It means it is the generalization of the independent sample t-test. These are the common uses. Field studies, experiments. One way is very much used in the laboratory experiments. See, when the experimental units are homogeneous in nature, then one-way ANOVA is used. So in most of the laboratory experiments, the cases or the objects are homogeneous. So we apply this one-way ANOVA in most of the laboratory experiments. One-way ANOVA is commonly used to test the following: statistical difference among the means of two or more groups. Two has written that this ANOVA t-test is also a particular case of ANOVA. ANOVA can also test the equality of two means. So statistical difference among the means of two or more interventions, with different notions. So statistical differences among the means of two or more change scores. You all are requested to put yourself on mute mode. And if you have any query, any question, please note down. We will be discussing each and every question after finishing this presentation. See here, both the one-way ANOVA and the independent sample t-test can compare the means of two groups. However, only one-way ANOVA can compare the means across three or more groups. Note, another note is here: if the grouping variable has only two groups, then the results of a one-way ANOVA and the independent sample t-test will be equivalent, obviously, because we are having only two groups. So in fact, if you run both the independent sample t-test and the one-way ANOVA in this situation, that is having two groups only, you should be able to confirm that this, because in ANOVA we use f-test, and so we know that t square follows f with 1 and n degree of freedom. Data requirement is same, that the parent population should be continuous, observation should be random, and dependent variable should be continuous. It means it should be quantitative in nature, and some more assumptions. So sometimes it is asked that what are the assumptions of ANOVA? Since ANOVA uses f-test, so the assumptions of f-test are applied here. So parent population should be normally distributed, and observation should be independent, that is sample should be random, and sample should be small. So these are some basic assumptions for this ANOVA. Now this is very important: homogeneity of variances. Sometimes it is known as sphericity test or test of sphericity. That is, in t-test what we do, we check the equality of variance of both the groups by Leven's test. So here we check the equality of variances of several groups, more than two groups. And that is known as the homogeneity, that is known as the problem of homogeneity of variances. That is variance approximately equal across groups. When this assumption is violated and the sample sizes differ among groups, the p-value for the overall f-test is not trustworthy. That is why we first test the equality of variances among the groups and then we go for the ANOVA. These conditions warrant using alternative statistics that do not assume equal variance. So then we go for some robust measures, such as the bond for the test or this Welch statistics is used there. When this assumption is violated, that is equality of variance, regardless of whether the group sample sizes are fairly equal. See, there is very much chance that the variances will differ if the size are different. If they are almost of equal size, there is rare chance to differ in variances. That is, the results may not be trustworthy for postdoc test. What is postdoc test? After that, postdoc means after that. So when the null hypothesis is rejected, then we apply some postdoc test to check the pair of observations. Which pair of group is responsible for the significance of the test? It is also known as multiple comparison test. Postdoc tests are also known as multiple comparison test. So when variances are unequal, postdoc tests that do not assume equal variances should be used. That Duncan's and so many tests are there. And obviously no outliers should be there in the data. If they are present, then we should handle them, whether they are of importance or not. Now, when the normality, homogeneity of variances or outlier assumptions for the one-way ANOVA are not met, these are the assumptions for the parametric test as well. So you may want to run the non-parametric Puskal-Wallis test. This test is equivalent non-parametric test to the one-way ANOVA. So researchers often follow several rules of thumb for one-way ANOVA. See here. Each group should have at least 6 subjects. 6 and lesser, if there are observations 6 and lesser, then we go for the non-parametric tests. Balanced designs means having thus almost same sizes in different groups. Same number of subjects in each group are ideal. Extremely unbalanced design, it means one group is having 20 observations, another one is having 80 observations. So this may give some biased results. Designs increase the possibility that violating any of the requirements assumptions will threaten the validity of the ANOVA, and that is F-test, which is used in ANOVA. Now, this is the hypothesis. We know that equality of several means, and alternative is that at least one is not equal to another one. So here one note is given that the one-way ANOVA is considered as an omnibus, Latin for all test, because the F-test indicates whether the model is significant overall. Overall means we are testing the equality of several means. See, this is ANOVA table. We have sum of squares, degree of freedom, mean sum of square, and the variance ratio, that is F-test. So here we have treatment, error, since we have only one-way classification for the assignable cause of variation. So it is treatment, and we calculate the error, that is random part, and the total variation. So this way we calculate the degree of freedom, and when this sum of square is divided by the respective degree of freedom, it gives the mean sum of square. And the ratio of the two variances is known as this, where error is always mean sum of square due to error is always in denominator, is known as the variance ratio, that is F. And thus we calculate on the basis of this SSR sum of square due to regression due to this treatment. So total sum of square is nothing but sum of square due to regression plus sum of square due to error. So total we have n number of observations. So total degree of freedom will be n minus 1. We have k treatments, so k minus 1 degree of freedom. And for the error, it will be n minus k minus 1 degree of freedom for the error. So this way we can calculate this. First we calculate the sum of square, then divide with their respective degrees of freedom, and then calculate the F statistics. That is variance ratio. After calculating the mean sum of squares. See here, this is all theory. That in some texts you may see the notation. Don't go on that. You just see. This sometimes this nu is known as n minus 1. This is notations in different books. Now we come to data setup and how to run this one-way ANOVA in SPSS. Let us see. Just click on analyze and then compare means and one-way ANOVA. Analyze, compare means, and here one-way ANOVA. So this type of dialog box will be opened here. Now you have to put the dependent list here and the factor, that is grouping variable, is here. And you can go for the contrast, postdoc test, you can select, and you can go for the options as well. See, if you go for the multiple comparison test or say postdoc test, you can select many. This Duncan test or Tucky test or Tucky B test. So I generally used to use this one Tucky for this. You can use LSD and least significant difference. You can use anyone for the postdoc test. Now let us see the procedure. So this way, this output will be there. You can see here, F is going to be significant because P is very much less than 0.05. So what does it mean? That the null hypothesis is rejected. It means all groups are not having equal mean. Then you can see it from the descriptive statistics table. You go for the descriptive statistics table and see there which mean is significant different from other means. You can find. Or through the multiple comparison test, we can see it. Now come to repeated measure ANOVA. This is the extension of pair t-test. What we do in pair t-test, we have only twice observations on the same group, one before or after. And suppose we are using some technique or say some diet chart to reduce the weight of some persons, and we are taking the observation on the first day, then after 1 month, then after 1 month, then after 1 month, it means at after 1 month, 2 months, 3 months, 4 months. So this is, we are taking the observation on the same sample, same group repeatedly. So that is why it is known as repeated measure ANOVA, and this is the extension of the pair t-test. So how it is done in SPSS? We just click on analyze, then go to GLM, general linear model, not go to compare means. General linear model, you will see their repeated measure ANOVA, and then you can go for that this way. We have taken observation on month 1, say month 2, month 3, and just go to analyze, then GLM, general linear model, and there you will see this repeated measure ANOVA. You have to define how many factors you are using to use their levels. You name the factor, you can say weight reduction or like that, and how many groups are there, how many times you have taken observations, not group, how many times you have taken the repeated observations. So 3 times here we have taken, so we will put 3 here and add then 3 times. You can give the major name, that is weight, say, and you can add. So you just define the group and put all the 3 months observations here, 1, 2, 3 here, You can go for the model, you can go for the postdoctors, you can go for the plot, and you can save some observation, and you can also go for the options we'll see during hands-on. And this way we can check this. So here this descriptive statistic table will be made for the repeated measure ANOVA. And then assumption of sphericity is very important. That is, it tests the equality of variances and covariances among different groups. So this way you can see here, this is much less test for sphericity, as we use that is Leven's test in case of independent sample t-test. Here much less test is used. So you can see here the p-value is very much greater than 0.05. So here we can say that the variance across the groups is same. It don't differ significantly among different groups. So it is okay. Then go with the repeated measure. See here. You can see here. Scarcity assumed, and this greenhouse gas test has been applied, and both are showing that it is significant. So it means you are using whichever technique you are using in weight reduction, it is applicable and it is effective. Not only applicable, it is effective in reducing the. It means the mean of every month is different from another one. It differs significantly. So this is the multiple comparison test. Since the null hypothesis has been rejected, so we'll go for the multiple comparison test. So one will be tested with 2, 1 with 3, 2 with 1, 2 with 3, 3 with 1, 3 with 2. So this way you can see here that 1 and third one is effective, but 1 and 2 is very close to each other. Because p-value is very high. So it is not, it both does not differ significantly. Or do not see here. And you can have idea from the descriptive statistics table. See here. For the first month, say second month, the value is 2.8, 2.4, but it is 1.9, almost equal to 2. So 1 and 2 do not differ significantly. These are the standard deviations. Sorry, see here, this is mean. It is 2020 and it is 22. So this is different from both, but these two are not different significantly. So you can see here. 2, 3 do not differ significantly. 1, 2 do not differ significantly, but 1 and 3 differ significantly. 1 and 3, this one, 1 and 3. So this one you can see. So this way we can apply these parametric tests to SPSS. Now let me do one by one. Okay. So first we have say one sample t-test. Let first we discuss the case study and then we'll do hands-on. Okay. So here we have a case study that ABC company launched a new brand of air conditioner AC for its customers and claims that under normal circumstances, the average life of air conditioner is 5,000 days. This is test value. A retailer wants to test this claim and has taken a random sample of 10 ACs. Retailer tests the life of the air conditions, these 10, under normal circumstances, and these are their life. The 10 AC are here, and these are the number of days. So now we will be testing whether the average life of this group is this 5,000 days of AC. It's taking a little bit more time.
So till the time it opens, just a basic question, any case study, how do we practice which test to be used? Means I know it is
It depends on the hypothesis actually.
Means for practice, if we want to practice, are we applying the right test or not? So could you recommend anything? How do we do that? I know experience only helps, but
See, if you are testing for a single group mean, you are going for the testing of the means or median. So we test for most of the parametric tests uses for the mean and non-parametric for median, equality of median. If you are going with the one group test, then either we can fit the distribution or we can test a particular value as we are doing here. And at last, I will be discussing a chart. I have got your question and I will be discussing after doing hands-on that there are basically 4 types of situations and 4 types of basic test will be there applied there. I will be discussing later. So now these 10 ACs are here and these are their lives. So go to analyze and then compare means and go to one sample t-test. So you days put here and the test value is 5,000 days. Then go for the option, no need of this bootstrapping and click on OK. So you will see here the one sample t study, we have 10 observations, the mean is 4880, standard deviation is 3.7 and this is the standard error for the mean. And now come to the one sample t-test, you can see the value of t is this, degree of freedom is 9n-1 and we know that and the p value is 0.311. It means it is very much greater than 0.05. So we can conclude here, we can draw inference that the average life of the AC is 5,000 days. Now come to independent sample t-test. We have a case study for every example. So first let me discuss the case study. The example to know whether the salary of male faculty member in private institution is equal to the salary of female faculty members. A researcher collected data from 20 male and 20 female faculty members in private institutions to know the differences in their average salary. So let us see whether there is difference in average salary or not.
सर इस केस में हम अनपेयर्ड टी टेस्ट लगाएंगे.
हाँ, ये अनपेयर्ड इंडिपेंडेंट सैंपल का मतलब ही होता है अनपेयर्ड. इंडिपेंडेंट है ना तो पेयरिंग नहीं हो सकती.
So if the sample size may be unequal, say 20 male and 10 faculty, 10 female.
No issue. लेकिन ये कहा जाता है that the difference should not be very high. because
What do you mean
equality of
by variance?
variance is also tested there. So you will have to test the equality of variance first through the Levens test. So if the variances of both the groups are not same, then we will have to adjust the degree of freedom, and then we will calculate the significant value, p value.
But for ANOVA, this is not valid. ANOVA, you have to
For
have same
ANOVA,
number.
for ANOVA also we do that. We check the equality of several variances through Matchley's test of sphericity. We
No,
also
mean the
test,
sample size may be different
may differ.
in different groups.
Yeah,
Okay.
only for the repeated observations, we take the
Sample
same
size should be same. Okay.
is constant.
इसमें
So
सर
now
वेरिएंस
here,
भी एक
see
बार
here, we have taken male as 1, we have coded, and female as 2. Now, in SPSS, we put the observations of both the variables in a single column, and we take the corresponding groups in another column. So we have coded as one as male and 2 as female. Now come to test whether the average salary of male is different from average salary of female. Let us test it through independent sample t-test. So we'll click on analyze and we'll go to compare means, and there you will see one option that independent sample t-test. You just click on that, this dialog box will be opened. So you have to put the numeric variable here. The main variable under consideration, it is numeric, it is metric. So, and the code will be put here, that is grouping variable, and you have to define the code. So we have coded 1 as male and 2 as female. So you have to put the numbers only. Click on continue and you can go for the options. And otherwise, there is no need of that. And you just click on OK. So you will see here, this is the summary statistics, summary table. You can see there are 20 male, 20 female. These are the average salary. So you can make a rough eye view estimation you can do here. You can have an idea to see the mean, that we are testing the equality of means and see whether there is significant difference in means of the two groups or not. So see here, it is the average salary for the male is 49,900, while it is 39,400 for the female. It has a significant difference of almost 10,500 rupees. So it must be a significant difference. Let us see through the t-test. So you can see here, first we will see the equality of variance through Levens test. So you can see here p value is very much greater than 0.05. So there is equality of variance in the variation in the salary of male and female. So it is good for the test. Now, so since it is non-significant equality of variance test, so we will use the first line and we'll see the p value of the first line, and here we can see that the p value is very much less than 0.05. It means the average salary of male is different from average salary of female, as we can verify from this descriptive statistics table.
So this means independent t-test does not have this condition that variance should be equal always. Variance can be unequal.
Not at all. That is why we test through Levens test. We test, as we discussed yesterday, if the equality of variance does not, fulfill the requirement, then what we do, we adjust the degree of freedom through a formula, and that degree of freedom may come in fraction as well, as we discussed yesterday.
Sir, in t-test, if the results show that that both one-sided p and the two-sided p, then which one shall we consider?
Here we have taken two-tailed.
How to?
But you can go for the one-tailed as well. You can set that. You can set that.
So how can I do that?
Here the purpose is only that we are not testing here that the salary of male is greater than the salary of female. Here we are just testing that it is different from female.
So how to set that?
You will have to put that value. You have to click on that p.
Where?
Automatically it tests the equality of with the two-tailed test only.
Sir, we should have applied normality before doing the independent
Yeah,
t-test.
that was skipped actually. So let us check the normality of this. But the both we will have to put the coded one data separately. We have to check the normality. So let us put it here. And now let us check the normality of this one. Okay, so go to analyze and then go to descriptive statistics. There you will see the explore option. And you just put this variance here and go for the plots, and you uncheck this one and just put tick on normality plots with tests and click on OK, then click on OK, and you will see the two test Kolmogorov and Shapiro will test. So here you can see the p value are say both the test through their p values are saying that the data is normal. P value is more than 0.05 for both the tests. So this way you have to verify whether the data is normally distributed or not.
सर कोई भी डेटा हो तो उसमें नल हाइपोथेसिस और अल्टरनेट हाइपोथेसिस हमें लेना ही होगा सबसे पहले।
बिना उसके चेक क्या करेंगे?
तो सर जैसे अब ये वाला केस है हमारा, ये सैलरी वाला कि हम देख रहे हैं, तो इन दिस केस नल हाइपोथेसिस क्या होगा सर हमारा?
नल हाइपोथेसिस होती है, नल हाइपोथेसिस मेक्स नो डिफरेंस। तो नल हाइपोथेसिस हम रखेंगे कि दोनों की सैलरी सेम है।
ओके। और
आ जाता है
ऑल्टरनेट
द
में डिफरेंस
हाइपोथेसिस
होता है।
ऑफ नो डिफरेंस इज आल्सो नोन एज नल हाइपोथेसिस। द हाइपोथेसिस ऑफ नो डिफरेंस वो है।
So how to set that means the parameter?
How to test the?
Sir, whether the result is one tailed or two tailed. You told that there is a way to put that in the software. So how can I do that?
I am unable to understand you. You just repeat that one, or anyone can repeat.
He's
Sir,
asking one
So
tailed
is
and
there a
two-tailed.
method for applying two-tailed test in the software?
Yeah,
Is there
yeah.
some specific
I'm just
method?
going to try that one. But here no such option is given here.
So it means by default it will show two-tailed.
Two-tailed. Yeah, here you have to define the cut point only. But it is for the single variable only. Let me check. I don't think there is such option in this SPSS. Not given. No.
So in the output sheet we have one-tailed and two-tailed. So we
Only-
have the option to see there.
Only it gives a two-tailed, I think. Because this significant value depends, or this t value depends on the whether one-tailed or two-tailed. See, it is showing that it is two-tailed, not one-tailed.
But sir, if it shows that both one tailed and two tailed results, so which result shall we pick? That's correct.
It depends on your purpose only. If you are interested in testing one-tailed, suppose you are interested in testing that the average salary of male is greater than average salary of female, then we will apply right-tailed test.
Oh.
In that case, we have to see the p value. It will make the difference only in the tabulated value. So we can do it through some tables. We can see that one, and calculated value is given here, and tabulated you see, and you calculate that one. Compare.
Okay. Okay, sir.
Compare whether calculated is greater than tabulated one. See, whenever calculated value of a statistic is greater than tabulated one, then we reject the null hypothesis. But it may be different for the two left-tailed and right-tailed tests. So let us do very fast as we are late. So now come to repeated measure and pair t-test. So let us do pair t-test. So let me open this one and that this case study as well. So here we have ABC University arranged a special faculty development program for one segment of its teachers. The university wants to measure the change in the attitude of its teachers after the FDP. For this purpose, it has used a well-designed questionnaire which consists of 10 questions on a 5-point Likert scale, say rating. 1 is strongly disagree and 5 is strongly agree. The university selected a random sample of 20 teachers, and let us see whether there is change in their attitude or not. So these are the scores before FDP and these are after FDP faculty development program. So let us do the pair t-test. Go to compare mean and there you will see the pair t-test. One by one you have to select and you can go for the option as well, but no need of that, and click on OK. So you can see here, this is the correlation, this is summary statistics, and this is the pair t-test. You can see here, it is also given for the two tab. And so tabulated value is here. There is no, much pain to calculate one way, one tail test. You just see the value for the one tail test, tabulated value at 19 degree of freedom, and we can compare it through the tablet with the tabulated, this calculated one. So here P value is 0.000, very much less than 0.05. It means the data is significant. The test is significant. It means the FDP is effective in changing the attitude of the teachers.
Sir, here mean is negative. So does interpretation is different? Like even the confidence interval, they are in negative. P value is also negative.
नहीं, स्कोर है वो तो मैं मुझसे कोई फर्क नहीं पड़ता.
ओके ओके सर, करेक्ट मी इफ आई एम रॉन्ग. सर ये जो नॉर्मलिटी आपने टेस्ट लगाया, अगर ये नॉर्मलिटी है तो देन इट इज ओके, आपने ये लगा दिया पेयर टी टेस्ट. अगर नॉर्मल नहीं होता, स्कोरिंग है वो, तो देन विल गो फॉर विल्कॉक्सन.
हाँ, तो इसका जो जैसे पेयर टी टेस्ट है तो विल्कॉक्सन रैंक साइन टेस्ट जो इक्विवेलेंट नॉन परमानेंट
पेयर टेस्ट है. थैंक यू सर.
सर इसमें कोरिलेशन हम कैसे रिपोर्ट करेंगे, मतलब कोरिलेशन कैसे हम इसको इंटरप्रेट करेंगे? कोरिलेशन
ये इंटर क्लास टाइप का है, समझिए. उसी ग्रुप का 2 बार ऑब्जर्वेशन हमने लिया है. सो द चेंज इज रिलेटेड टू दैट वन प्रीवियस.
मतलब we can say
that is the effect of that say that force.
नहीं, इसमें कोफिशिएंट ऑफ कोरिलेशन बोलना ठीक है? मतलब
कोफिशिएंट ऑफ कोरिलेशन रिपीटेड ऑब्जर्वेशंस हैं, तो
क्योंकि इसमें 2
क्लास भी नहीं है और निकाल लिया गया है. उसका क्यों निकाला गया है पता नहीं. कोरिलेशन बोल सकते हैं अगर 2 ऑब्जर्वेशंस, बट दे आर नॉट इंडिपेंडेंट एक्चुअली. तो इससे क्या होता है, क्यों नहीं बोल सकते हैं? वी कैन से बिकॉज कोरिलेशन इज आल्सो रिलेटेड. We calculate the correlation for the related observations only. So here one observation is related to the another one through the change. So definitely we can calculate. Now come to one-way ANOVA and then repeated measure ANOVA. This is ANOVA, and for that this is the case study. Store promotion. Okay. Here an experiment is in which a major departmental store chain wanted to examine the effect of the level of the in-store promotion The experimenter wants to know the impact of the in-store promotion on sales. In-store promotion was varied at 3 levels: high promotion, medium promotion, and low promotion. So we see whether these type of promotions are going to affect the in-house store promotion or not, whether they are effective in enhancing the sale or not. So these are the, we have coded high promotion as 1, medium promotion as 2, and low promotion as 3. So now come to analyze and then compare mean and go to one-way ANOVA, and you have to put this dependent variable here and this factor here, and you can go for the polynomial you can use, and go for the postdoc test, say Taki, and you can go for the options, maybe descriptive and homogeneity of variance test. Okay. And just click on OK. So here you can see that for all this homogeneity of variance is okay. All the group are having the same variance because p values are very much greater than 0.05. And these are the descriptive statistics. These are the mean. So here from mean you can have idea that whether it is going to be significant or not. But here come to the ANOVA, you can see only the third one. Between group you can see here, it is going to be significant. Now, so because of the significance of the two groups, now we come to multiple comparison test. Which pair of treatment is going to be significant? So you can see here high promotion with the medium promotion is also significant. High promotion with the low promotion is significant. Everyone is significant here, you can see. So, and you can have idea from this one that mean value is very much different. It is 40,600, 67,900 and 93,700. So mean is very much different. So this way we can see that the low, high and medium promotion impacts differently, but it is it's significant. It has significant difference on the same.
तो इसमें दो क्वेश्चन थे। एक तो इसमें भी नॉर्मलिटी तो हम टेस्ट करेंगे ही ना तीनों,
लेकिन नॉर्मलिटी हम इसलिए नहीं चेक कर रहे हैं क्योंकि हमको हर ग्रुप को अलग अलग निकाल के चेक करना पड़ेगा 1 2 3। बट एसपीएसएस में क्या है ना कि एक साथ रख के कोड करना पड़ता है।
और दूसरा सर इसमें जो पॉलिनोमियल और लीनियर था, वो पॉलिनोमियल और लीनियर कब यूज करते हैं?
मॉडल की बात है, मॉडल कौन सा यूज करते हैं,
तो कौन सा कब करना चाहिए?
जनरली हम लीनियर यूज करते हैं, लेकिन पॉलिनोमियल आप चाहें तो एक टर्म और बढ़ा देते हैं उसमें, वो तो उसी का पॉलिनोमियल उसी का बढ़ता है ना, एक्स स्क्वायर ऐड कर देता है उसमें इस टाइप से, और थोड़ा रिफाइंड इंफॉर्मेशन देगा। लेकिन कई बार क्या होता है बहुत नहीं वो उसमें वो कंट्रीब्यूट कर पाता है, लीनियर ही बेस्ट।
सर एक क्वेश्चन था, लेकिन ये इंटरप्रिटेशन कैन यू रिपीट अगेन, लाइक इन दिस हाउ विल यू से दैट व्हिच इंटरवेंशन वाज बेस्ट?
Which intervention were
best? Like it is comparing between groups. Now if we have to
high promotion,
okay,
वो तो मीन देखे ना, जिसका ज्यादा होगा वही अच्छा होगा।
okay, okay,
सर ये आपने एक कॉलम सिलेक्ट करके जो ये थर्ड लास्ट पे ये ए और ये 1 जो लिखा हुआ है, यू क्लिक दैट, आई थिंक वो थोड़ा सा फास्ट गया मेरे लिए, वो क्या है? लाइक when you open the SPSS में data, yes, this red one.
Which red one?
This third last A and 1 लिखा हुआ है जो ऊपर help के नीचे,
ये
यहाँ पे अपने, what did you do that?
ये अल्फा न्यूमेरिक है मैम, जो हम कोड करते हैं, जो न्यूमेरिक अल्फा मतलब अल्फाबेटिकल को जो न्यूमेरिक में चेंज करते हैं कोड, उसको दिखाता है।
ओ अच्छा, ओके
ये देखिए ना, इधर न्यूमेरिक है इधर अल्फा है, तो अल्फा न्यूमेरिक।
ओके।
एक सर इम्पोर्टेंट क्वेश्चन अभी एक मैम ने पूछा था कि जैसे लो मीडियम और हाई प्रमोशन है, वो तो ठीक है, हाई तो दिख रहा है कि बेस्ट है, लेकिन अगर मुझे ये कंपेयर करना है कि ट्रांजिशन बिटवीन लो टू मीडियम एंड ट्रांजिशन बिटवीन मीडियम टू हाई कौन सा बेटर है, तो वो कैसे कंपेयर करेंगे?
डिफरेंस कैलकुलेट करें मीन में।
मतलब मीन नहीं सर, स्टैटिस्टिकली डिफरेंस, जैसे चेंज जो हुआ 30% चेंज हुआ फ्रॉम लो टू मीडियम, और मीडियम टू हाई में चेंज जो आया वो एक वैल्यू आएगी बिटवीन दी टोटल जो भी उसकी वैल्यू है, लेकिन वो स्टैटिस्टिकली डिफरेंट है या नहीं वो कैसे पता चलेगा?
स्टेट चेंज तो उसी से दिख रहा नहीं, ये जो पी वैल्यू अगर हर एक की आ रही है तो चेंज की वजह से ही तो डिफरेंट है वो।
लेकिन ग्रेटर चेंज कौन सा है सर, वो अगर मुझे देखना है, मतलब ए टू बी और बी टू सी, विच चेंज इज ग्रेटर?
तो वैल्यूज में डिफरेंस निकाल लीजिए, फिर उसमें टी टेस्ट अप्लाई कर दीजिए, दो के डिफरेंस आ जाएंगे ना। 1 से 2 का डिफरेंस निकाल लीजिए, ऑब्जर्वेशन आ जाएंगी। 2 से 3 का डिफरेंस निकाल लीजिए, ऑब्जर्वेशन आ जाएंगी। एंड यू कंपेयर देम थ्रू इंडिपेंडेंट सैंपल टी टेस्ट।
अच्छा, राइट, जी, ठीक।
अब हमको लास्ट में क्या करना है, रिपीटेड मेजर एनोवा।
So the same thing is given also in the multiple comparison group, no? So why we need to do the paired the independent sample t-test for
There
each?
is no other way to test the multiple comparison test. Actually, multiple comparison test uses the t-test only, where we use testing the two groups only to check to find which pair of treatment is going to be significant
Yes, sir.
for rejecting that the whole null hypothesis.
That is what we can see it from the multiple comparison group.
That is
We
why
don't have to.
वो एक साथ रख देते हैं, we put all the tests together. That is why multiple comparison test. Otherwise, one by one you can test through t-test. This is the case study of diet. A dietitian introduced new diet chart plan to reduce weight loss. The dietitian took 15 women who considered themselves to be in need of losing weight. यहाँ हम पुरुष भी कर सकते हैं. And put them on this diet for 2 months. Their weight were measured in kilograms at the start of the diet, and then after 1 month, 2 months, 3 months, and so on. So let us do the final. These are the weights: baseline, 1 month, 2 month, 3 month. So we'll see whether that exercise or diet is going to be significant or not. So just click on analyze, go to general linear model, and here you will see repeated measure ANOVA. Now you have to define the factors. Say you can say weight reduction or weight loss, whichever you think. And here we have 4 actually levels we can add. Okay, here underscore will take not space, and you can give the name diet or whichever you think, and just define. You will see here, you select all 4 and put them here. You can go for the model, full factorial, okay, no issue. You can go for the contrast if you think, otherwise no need. And you can go for the plot if you wish, and you can go for the postdoc test, no need, and then click on okay. So here you will see that this is the multivariate test. You can see for weight loss, all are going to be significant. And this Mochli's test is showing that the variance among the group is different in 1 month, 2 month, 3 month, 4 month. And now come to this final within test subject. You can see everyone is going to be significant. When sparsity assumed, then it is significant. When sparsity not assumed, then we are using these different tests. Say this greenhouse gazer test, then field test, but everyone is showing significant. Now come to this final test. you can see here. We have used different type of models, linear, quadratic, cubic. In every model, it is going to be significant. And finally, you can see here for the diet one, that intercept term, and this is error term, you can see that it is going to be significant. It means that the final ANOVA table is showing that the diet which has been given to the cases in reducing the weight loss is effective in reducing the weight loss, because it is having significant difference. The p-value is less than 0.05.